Ma'am, my slide is visible, ma'am.
Yes, ma'am, your side is visible.
Ma'am,
Yes, ma'am. Yes, ma'am, we can able to see your slide, ma'am.
shall I proceed?
Yes, ma'am.
Okay. Good morning, everyone. My topic is under the supervised learning, module 2. Uh, First of all, what is supervised learning means? The image gives some meaning. So there are more number of labeled data. So this is the basic difference between supervised learning and unsupervised learning. So our module 2 contains the supervised learning. So in the supervised learning, all the data has some labeled value, whereas unsupervised learning, the data are not labeled. This is the main important point behind in the supervised learning. So in the supervised learning, the data should be labeled. Then only we can apply the machine learning algorithm based on the our needs. So the image gives some meanings. There are oranges and strawberries. It is an apple. That is a strawberry. Machine learning algorithm or model. So it categorizes the it is a strawberry and the apple data. This is the basic things behind in the supervised learning. This is the agenda of this session, considering the module 2. So the first broad topic is dimensionality reductions. Under this dimensionality reductions, so first one is a subset selection. Another one is the principles component analysis, shortly we known as the PCA. Then another topic is regressions. So under this regressions, linear regressions, then linear methods for the classifications, that is linear regressions, then Navy Bayesian methods and Decision tree. So these are the some classifications method comes under the linear method. The first one is the linear regressions. In this linear regressions, we are going to discuss one variable and then multivariable linear regressions. So the third part is case study. So classifier for the phase deductions. This is the overall agenda of today's sessions, both afternoon and forenoon and afternoons. So first topic is dimension. This is the overview of today's session. So the detailed topics under this module 2, supervised learning. First one is a dimensionality reduction, then subset selection, then principal component analysis. Then second part is regression, linear regression with one variable, linear regression with multiple variables. Already we saw in the previous slide. Then the blue part is going to cover in the afternoon session. That is solution using gradient descent algorithm and matrix method, and what are all the basic idea of overfitting in the regression. So what is overfitting? How we are going to remove the overfitting by using the normalization methods. So in the linear methods for classification, that is logistic regressions, then Navy based decision tree algorithm using ID3. The case study, so develop the classifier for phase deductions. So this is the detailed topics under module 2. So first topic is dimensionality reductions. So in the picture says some meaning regarding the dimensionality reductions. So this is the cube. This is the three-dimensional cube. So that is converted into two-dimensional. Again, it is converted into one-dimensional. So this way we are going to reduce the dimensions. This is the core concept of the dimensionality reductions. That is, it is a n dimensional. So that is a 3x3 or 4x. Any dimensional is reduced into n-1. Again, it is divided into single dimensional. So dimensionality reduction reduce the number of input variables in the data set. So for a given the data set, we have any number of features, but all the features is not used for predicting some values or classifying the values. So we cannot use all the features. For example, for a student database, we are having the student's register number, roll number, the name of the student, then address, mobile number, then mail ID, then Aadhaar number, then 10th mark, that is SSLC marks, and 12th mark plus 2 marks as SSLC marks. Then now he is studying, suppose third year means first year marks, then second year CGPA, then fifth semester continuous assessment marks. This is the data we are having. So now we are going to predict whether the students is going to get pass or not in the current fifth semester in semester exams. So for this question, not all the features, we cannot use all the features. Suppose the mail ID will not predict whether the given student is the mail ID will not use. Similarly, name also will not use. What are the main features we need to predict the given student is get pass or not? Maybe here basic foundations, that is a 10th mark or 12th mark and 12th mark, then first year consolidated CGPA marks, then second year CGPA, and moreover now internal exam marks. So these are the features is very essential to predict the given student will get pass or not. So the remaining features is not that much importance. So this way, this is the feature selections or subset selections or dimensionality reductions. So reduce the number of input variables in the data set. So why we are doing dimensionality reduction means less computing or training time. If we are having more number of data with more number of features, so for example, for a feature, in the data set it has 80 or 100 features, means by using the all features, the computing time is more. So that is it is a less computing and time. And then redundancy is removed. Suppose there's some redundant data is there, means by next, the complexity of classifier or regressor depends upon the number of inputs. So definitely, if we are giving the less number of inputs, means the classifier or regressor will give the 100% accuracy. If the input is more, means both time and space complexity affected. So this determines both time and space complexity and the necessary number of training samples to train such a classifier or regressors. Although it is a necessary number of inputs is needed predicting the classifier or regressions. So there are two methods for reducing the dimensionality. So first we see dimensionality. What is dimensionality means? So reduce the number of inputs in the data set. For reducing the dimensionality, there are two approaches. One is the feature selection and feature extractions. These are the two main concepts. So feature selection means, in the feature selections, we are interested in the feature selection, finding the K of D dimensions that give us the most information, and we discard other D. We discussed in the student database, the mail ID, Aadhaar number, name, even gender, phone number will not give the more information, that is academic or studied information regarding the particular students. So we reduce we eliminate the unimportant features from the data set. So in the feature selections, we are interested in the feature selection, finding K of D dimension that give us the most information. So what are the features we are selecting from the data set is it will give the most information regarding the data set. Feature selection methods that choose a subset of important features. So another we have to concentrate choosing the subset of important features, pruning the rest and feature extraction methods that form the fewer and new features from the original inputs. In the subset selection method, the second method is the subset selection. We are interested in finding the best subset of the set of features. The best subset contains the least number of dimensions. This is the important one. So if the subset of the features giving the more dimension means, again the complexity will occur. So the best subset contains the least number of dimensions that most contribute the accuracy. So never we compromise the accuracy. We discard the remaining. We discard the remaining unimportant dimension. Using the suitable error function, this can be used in the classification problem. So there are two approaches in the subset selections. One is the forward selection, another one is a backward selection. So in the dimension reducing the dimensionality, there are two approaches: feature selection and feature extraction. In the feature selections, again they divided into two approaches: forward selection and then backward selections. So in the forward selection means we start with no variables and add them one by one. At each step, adding one that decrease the error the most until any further additions does not decrease the error. That means to decrease it's only slightly, not absolutely. So the forward selection method, we start with one by one. At each step, adding one that decrease the error the most until any further addition does not decrease the error. Then second approach is backward selection, that is the reverse of the forward selection. We start with all variables and remove them one by one. At each step, removing the one that decrease the error the most. This subset selections. The next part is feature extraction. So feature extraction, we are interested finding the new set of k dimension that are combination of the original d dimension. So the feature extraction, we cannot delete any features. That is only the dimension only the reduced. Here we never skip any features. The feature extractions, we are interested in finding a new set of k dimensions that are combination of the original d dimensions. So the best known method under this feature extraction is PCA. This is our next topic: principal component analysis, and then linear discriminator analysis, which are the both linear projections method. So the feature extraction, the PCA is a very popular method. So one thing you have to kept in your mind, feature extractions, we never skip any features, rather than the dimensions only reduced. Whereas the subset selections, we are choosing finding the best subset. So feature selection is another name for subset selections. In your syllabus, it is represented subset selection, but both are feature selection and subset selection, both are same. Selects a subset of existing features. Feature extraction, it is a transformation method, that is from one dimensional to, that is n dimensional to one dimensional. So creating the new features by transforming the existing ones. Here we are not skipping any features. The best known and most widely used feature extraction methods are principal component analysis. We will discuss detail in later. PCA means what is PCA and what is why we are doing PCA. So PCA means principal component analysis. This is one of the reduction technique, feature reduction technique. Suppose in our data set there are 100 features, features 1, feature 2, feature 3, etc. Feature 100. So all the features, that is F1 to 100, all the features will not give the most important features regarding the data set. For example, PC1, we are for 100 features data set, we can calculate 100 PC. We can calculate 100 principal components, but not all the 100 principal components will not give that much data regarding the data set. For example, the PC1 will give 80% of the data. It will give the information 80% of the data set, whereas the PC2 will give 15% of the data. The PC3 some 3% of the overall data. So even we are having PC up to 100, the 3 is enough to get the idea regarding the data set. So 98 is a good percentage. So the one thing is, for a n number of features, we can calculate or we can find n number of PC, that is components, principal components. But all the PC component will not use for the data reductions. Based on the percentage of the information given by the principal component, we can take it in the next step. Another next. That is detailed explanations regarding the principal component analysis. Principal component analysis is a well-known dimension reduction technique. Already we discussed it is a well-known dimension reduction technique. It transforms the variable into a new set of variable called principal component. This is the important point. It transforms the variables or features, both are same. Variables into a new set of variables called principal components. These principal components are linear combination of the original value and the orthogonal values. The first principal component accounts for the most of the possible variations of the original data. The second principal component does its best capture of the variance in the data. There can be only two principal components for the two-dimensional data. Already we discussed, if the data set having n number of features, means we can calculate the n number of principal components. If the data is a two-dimensional set, we can find only the two principal components. So this is the principal component algorithm. Step 1 is, first we have to get the data, that is the data set. Step 2 is compute the mean vector. Mean vector is nothing but the mean of the given data. Then we have to scale the data. Subtract the mean from the given data. Then calculate the covariance matrix. Calculate the eigenvectors and eigen. 6 is choosing the components and forming the feature vector. Step 7 is driving the new data set. These are the steps behind in the first get the data, compute the mean. So by using the means, we have to scale the data, that is subtract the mean value from the given data. Then next step is we have to find the covariance matrix. Then calculate the eigenvectors and eigenvalues for the covariance. After that, choosing the components and forming the feature vector. And we have to transform the original data into the new dimension. This is the mathematical explanations of the principal component analysis. This is the features x1 and x2. So there are two values, how many features means 1, 2, 3, 4. There are 4 features. So first simply we have to calculate the mean, that is x1 bar. Just adding all the 4 values divided by number of features, that is a 4. So for x1, the mean value is 8. For x2, the mean value is equal to 8.5. x2 bar. So in the algorithm, the first step is calculate the mean. Next, we have to calculate the covariance matrix. So before that, this is the small values, some small values of the features. So we no need to scale the data. We can go with the as it is. If the data are too large, we reduce the scaled data by reducing the mean value. That is a 4 minus 8 minus 4, 8 minus 8, 0. So here the given data is a very simple, so no need to scale the data. If the data is a wide range, we go with the scaled data. So the next step is we have to find the covariance of the matrix. So what is the covariance in matrix and why we are calculating the covariance means what is the correlations between the 2 features. So that for that we have to calculate the covariance of the matrix. So for the given x1 and x2, that is covariance of x1, x2, covariance of x1, x2, x2, x1, and then x2, x2. So this is the formula for calculating the covariance in matrix. For covariance of x1, x1 is equal to 1 divided by n minus 1. Here n is equal to number of features. Here the number of features is 4. So n minus 1 up to 1 to n. So x1k minus x1, that is x1k minus x1 bar. That is simply subtracting the mean value. This way we calculate the x1, x2. Here, covariance of x2, x1 is equal to covariance of x1, x2 both are same. So 11. For both covariance of x2, x1 and covariance of x1, x2, the same value minus 11. So this is the matrix obtained from the previous step. Covariance matrix is 14, 2,3 for covariance of x2, x1 and x1, x2 same minus 1. So this is the covariance matrix for the given data set. By using simple Excel sheet, we can do it with values. So this is the given. There are 10 values. Then another feature is y. So we have to calculate the mean. For scaled data, we have to for scaling purpose, that is the original data is subtracted from the mean value. This is for scaling purpose. That much needed. Next, we have to calculate the covariance of the x, x. For calculating the covariance, first we have to calculate the x minus x bar, the whole square. So here we are calculating the x minus x bar the whole square, y minus y bar the whole square. So here, after the x minus x bar whole square, we will get this value. Then this is the formula, that is sum divided by n minus 1. Here n is equal to 10 values. So 10 minus 1, 9. Similarly, this is the covariance value for x, y minus y bar, the whole square, of x minus x1 into y minus y1, the whole square. So this way, the second step is, next step, we have to calculate the eigenvalues and then our eigenvectors. Eigenvalues of the covariance matrix. The characteristics equations of the covariance matrix is, that is 0 is equal to determinant of S minus lambda I. Here S is equal to nothing but our covariance matrix. So lambda into I is nothing. So that is equal to 0. So the determinant of, we have to substitute, we know the S value, that is 14, then minus 11, 23. This is minus from the lambda identity matrix. So this is a 2 cross 2 matrix. So we are multiplying the lambda I minus S, that is S minus lambda I, 14 minus lambda I, then minus 11, then minus 11, 23 minus lambda. So how we are calculate the determinant, that is a 14 minus lambda into 23 minus lambda minus these two values, diagonal values. So this way we are calculating the determinant of the given matrix. So after that we are getting the quadratic equation. By solving the quadratic equation, we will get the two values, that is lambda 1 and lambda 2 for 30.38 and 6.61. So here we are selecting the which lambda value is the highest value. We will take that value. So this is the third step. Vector or eigenvectors. So equation, before that we calculate the eigenvalues. Now we are going to calculate the eigenvector. Why we are calculating means we have to convert the dimension from one type to reduced dimension. For that we vectors. This is for the both magnitude and vector concept. Already we know there are two types of data. Another one is the vector data. So vector data, it is having magnitude along with the directions. So here also vector coming to the picture to adding the magnitude as well as the directions. So equation to find the eigenvectors, mx equal to lambda x, where m is the covariance matrix. Already we calculated covariance matrix, and x is equal to eigenvector, lambda is equal to eigenvalues. Here we are find out the x value. The remaining covariance matrix and eigenvalue we find out in the previous steps. So step 4, so computation of the eigenvector. So u is equal to u1 and u2. Here we are having only the two sets of the data. So that is 0, 0. S is the covariance, lambda I into u. So just already we know this values, that is multiplied by the u1 and u2. Again, we multiplied the first row, first column. So 14 minus lambda into u1 minus 11 into u2. So this is a simple matrix multiplication. In this case, it's true. This one is 2 cross 1. So both this number of columns and here the second matrix row. So both are to satisfy the matrix multiplication rule. So for that we multiply this two matrices. So the capital U is equal to U1 and U2. So here we calculate the determinant, that is a 14 minus lambda into U minus 11 U2, that is equal to form the equation by using this matrix, that is equation 1 and equation 2. So we can select any equation. For example, we are getting this first equations. After simplifying these equations, we will get U1 divided by 11 equal to U2 divided by 14 minus equal to t value. So we are solving this method, that is U1 is equal to 11t. We substituting the U1 value in the second equations, we will get this value. So before find out the eigenvector, we compute the length of U1, which is given by the square root of 11 squared minus 14 minus lambda 1, the whole square. The value is equal to 9.7348. So the for eigenvector E1 is calculated by 11 divided by the value divided by the U values, that is unit eigenvectors. So divided by the unit eigenvectors. So after simplifying, this is the E1 values. So our eigenvectors. So this is the mathematical, little bit difficult for to understand the method, but Python, it is a single shortcut. Everything is that comes under the packages. So in the Python implementation, it is very, very simple. So don't bother about the calculation part. In a single statement, we will do this, all the eigenvalues and eigenvectors I will show later. So computation of the first principal components. So eigenvector transpose. So why we are going to transpose? We have to calculate the column wise. So just to transpose the matrix. So here the first value is 0.5574 and minus 8303. So this is the first eigenvalues. Then this is the transpose matrix. So after simplifying, this is the value, that is principal component of the first features. So this way we calculate the remaining features. So first principal components for -4 and then 3. So here in this case, they are having the 2-dimensional, whereas after calculating the principal components, it comes under the single dimension. Here we are not removing or neglecting any features. So the transformation, the dimension only reductions. So 4, 11, there are 2 dimensions. It is converted into, this is the thing. So after that, we have to next step is geometrical meaning of the first principal components. So already we discussed in the algorithm steps. So here get the data, compute the mean vector, subtract the mean from scaling the data. Then calculate the covariance matrix. By using the covariance matrix, we have to calculate the eigenvectors or eigenvalues or eigenvalues. We can call it anyway, eigen or eigenvectors. Then step 6, choosing the components and forming the feature vector. We already found the principal components and forming the feature vector. Then the final step is deriving the new data set. So this part is, so the geometrical meaning of the first principal components. So this is the given data set. So the first data set, the first point is 4, 11. So 4, 11 is marked here. Then second data 8, 4. So here 8, 4 second data. So likewise 13, 15. So 13, 15. Then 7, 14. So this is 7, 14. So this way that this is the mean value, that is x bar, comma x1 bar, comma y1 bar. That is our 8, our mean value is 8, 8.5. That is x1 bar and x2 bar. So here this is the our mean value of x1 bar and x2 bar. So hereafter we consider this is the origin of the new dimensions. So again we have to start the points from this only value. So our first E1, our E1 value is minus 4.3055, minus 4. So minus 4 in the sense it comes here only, this point. So this point we just draw the line. So then E2 is equal to somewhat positive directions. So we draw like this. So this is the new dimension for the features. So that is x1, x2, that is the E1 and then E2. So this way now we have to fit the original data. So our original data is equal to here that is 13, 5, then 8, 4, 4, 11, 7, 4. So in this, just to project the original data fit on the new axis. So this way this model predict this values. So it is transformed into the new dimensions or new faces, geometrical faces. So this way the 4 original values is distanced from this predicted values. This is the new dimensions of the values. Then the application of PCAs are, it is used in Netflix movie recommendation, grocery shoppings, fitness trackers, car shopping, real estate, then manufacturing and quality control, sports, analytics, renewable energy, and then smart cities. So these are the some variety of applications using PCA. Then advantages of the PCA, it prevents overfitting. What is the overfitting? This also comes under topic. Then speed up other machine learning algorithms. Improves the visualizations. So it will give some clear idea regarding the data or predictions value. Of course, it is a dimensionality reduction. So one of the PC is one of the methods under the dimensionality reductions and noise reductions. Noise in the sense unwanted data or redundancy data. These data are reduced by using the PCA. So this is the final summary of the PCA, how the PCA will work. So step 1, standardize the data. So calculate the covariance matrix, then compute the eigenvectors and eigenvalues, then select the principal components. So how will you select the principal component means which will give the higher components. Then next to fifth step is project the data into the new basis, that is new axis, already we discussed. So first to standardize the data, then compute the matrix covariance matrix computation, then eigenvalues and eigenvectors, and then vector feature vector. So that is the project data onto the new basis. So this is the overall view regarding the PCA. Now we will see one implementation of the PCA by using the Python Colab. This is the simple implementation, PCA implementation using Colab. So first we have to import the necessary packages, NumPy, Pandas, Matplot library, .pyplot as plot. Then from the NumPy, the linear algebra. In that linear algebra, we are importing the packages eigenvalues. That is, the mathematical part is very tough to understand, but in this Python, it is readily available. In one shot, we can find the eigenvalue factors. So we have to transfer the data from n dimensional to reducing the n minus 1 or 2 dimensions. Based on that, we have to calculate the both magnitude and the directions. So the eigenvalue and eigenvectors is used. So define the data set. For the simple data set, so there is a marks, np.array 3, 4, 3, 2, 8, 6, 9. There is a print marks. So that is a in physics and maths. Consider this is a physics marks of the 2 students, 3 students, physics and maths subject marks of the 3 students. So this is the NP, that is number by array. It is converted into make it as the data frame. So marks df is equal to pd dot data frame marks comma our data frame is ready. So the data frame looks like so. So there are 3 students. So physics marks and maths marks. This is very simple data for understanding purpose. So then plot scatter marks underscore df, that is a data frame. This is a user defined variable name, physics and marks. We have to plot the physics marks and the maths marks. So this is 3 students marks. So the first student's marks is 3, 4. So 3 is a physics mark and the 4 is a maths. Similarly, second student marks 2, 8. So comes here 2, 8. The third student 6, 9. So in x-axis 6, that is physics. In this 9. So this is a theoretical representation of the given data. Next, making the data mean centric. So we have to find out the mean. Simply mean by column is a variable name, user variable name. So it is already the mean function is available in the NumPy. So np.mean marks.transport axis 1. Why we are doing the transpose means we have to calculate the column wise. So transport matrix is here using here. So print the mean. So for the physics, the mean value is equal to 3.6. For maths, the mean value is equal to 7. For example, maths like this, marks are transport like this way. That is, row is converted into column. Then scale the data. So scale the data is nothing but marks minus mean column. So all the values are subtracted from the mean. This is for the standardization of the data. Next, we have to find the covariance matrix. This is the simple step. So covariance matrix equal to NP. It is already inside in the NumPy packages. Dot T. That is again, once again, we have to transpose the data. So this is the given, this is the covariance matrix for the given data set. So this is the calculated for the sealed data. Then, so in the simple step, we find out the covariance. Whereas in the mathematical steps, we have to find out x minus x bar, then x minus x bar, the whole square, then x minus x bar, the whole squared into y minus y bar and the whole squared. Then we have to divide the value sum divided by, that is all the values divided by n minus 1. So here the value is equal, total value is equal to 10, n minus 1 is equal to 9. So this way we have to calculate. So this is the covariance. This is our covariance of the matrix. So the entire step is replaced by this simple function, that is covariance of the given data matrix. That is this scaled data dot this values. Then next step is we have to find the eigenvalues and eigenvectors. So eigenvalue comma eigenvector is equal to eigenvalue of the, how we are calculating the eigenvalues and eigenvectors by using the covariance matrix. So just we are giving eigenvalues of covariance matrix, print eigenvalues and eigenvectors. So this is the values for this given covariance matrix. Get the original data projected to the principal's component as a new axis. So here we are going to transfer the values from the new thing. So this is the final output. So this is the manual step-by-step procedure for finding the principal component analysis. Now the same method is calculated by using the Skyline method. So from Skyline decomposition, input PCA. So the PCA is already there in the escape plan. And whereas here, up to this, we did individually. But in Skyline, there is a package or library functions available under the PCA. So PCA is equal to PCA of n components 2. So here our input is 2 components. Underscore transfer marks. So this is the given. This is the output. Only the 3 lines will do all these steps, previous steps, from this to this, this to this. This will do only the three lines will do all the above steps. So our answer is same for calculating the new PCA. So here also -2, 9.1, 9154, etc. That is e power 0. So anything over 0 is equal to 1. So we have to take this value. So this is these two are same. Whereas the e power -60 is very, very less. So we neglect this values. E power -60 is 0.000 something. So we neglect this values. Next, PCA explained variance ratio. So this is a little bit hard to understand. So it is converted into ratio. Now this one is the PCA is equal to 75% and then 25%. That is PCA1. PC1 is 70%, and PC2 is equal to 25%. The data frame for clear understanding. So this is the PC's values. Then we plot the values of PC1 and PC2. So this is the representations of the new phase. So inverse transform. So transform from one axis to another axis. So for PCA inverse transform, PCA fit transform for marks. So this is nothing but our given input 342869. So 342869. Okay. Once again, we transpose the matrix. We will get the original value. How much weight each variable has in the PC? So loading the data for a PC components, PC1, index physics and max. So for physics, there are two components, PC1 and PC2. For max, we are having the PC1 and PC2. So here, which is giving the more accuracy, that is enough. For example, here the 75% and then 25%. We will use the 75% values. This is the implementation of Python implementation of the PC. Just I copy the code in the chat box. PC1 is good means it will give more accuracy of the regarding the features. So PC1 is suited for any n number of features. We can that much number of PC values, that is PC1. Suppose in our data we are having 100 features means we can calculate 100 PC values. But among the hundreds, we cannot take all the PC values. Which PC values give the higher accuracy means that is considered for the dimension reduction. So that is, this is in this case, the first PC1 give the 75%. Then second one is give the 25%. So the PC1, this is the PC1, this is the PC2. Why only two values? Here we are giving only the 2 marks, that is physics marks and maths marks. So n number of features, we will find out the n number of PC values. Among the n numbers, we will take the which one is a higher accuracy, that is considered for the dimension reduction. So the remaining pieces is not necessary. This way we are reducing the dimensions. Okay, ma'am, sure. I will share. But don't change anything in the coding. Just you copy the notebook and do it. Just I will give 5 to 10 minutes to doing this request access. Now check, no? Okay. Once finished, let me know. After that, I will continue the next talk. Okay, sir, I will share. I will share my book to the coordinator. From the coordinator, we can take it. Shall I start the next topic, linear regression? Okay, sir. The next topic is regression. So regression algorithms are a subset of supervised machine learning technique, which are used to predict the output values based on the input labeled data. So at the beginning itself, I told under the supervised learning, all the data are labeled one. If the data is not labeled, we go with the unsupervised learning. That is clustering method. It is a very, very important. If you are doing any research means, first you have to clear idea what about your data and what are all the things inside in the data and which algorithm. There are a lot of AI, ML algorithms are available. Which algorithm is suitable for your data? So if your data is image means with some deep learning or some other methods, CNN or RNN. So you have to clear. After that, whether your data is only the static data or continuous data or nominal data, categorical data. So you have to key note on your data set. So you have to go through the deep study regarding the data set. After that, only you are going to apply the any AML algorithms. So the clear understanding is very, very important, which you are using in your research work. So the regression algorithms is a subset of supervised machine learning technique, which are used to predict the output values based on the input label data. So if you are giving any input data, it will give some predict the output value. The very first slide, the introduction slide, I put one image now. There are apples and strawberries. The labeled data is given to our machine learning model. It will predict whether the given image is strawberry or apple. So this is the concept. Then what is regression means? From the features to predict. Predict in the sense in future we will predict whether tomorrow the rain is come or not. The rain will come or not. This is a prediction. So this is the data. So input X, features derived from the data. So what are all the features? Already we know. So the regressions. So learn from X to Y relationship. What are the relationship between X and Y? Then apply the intelligence. We will predict the Y. Continuous output or response to the input. So this is a major concept behind in the regressions. So the relationship between the two features. Which are the main application of the regression model in models in machine learning? To predict the real estate values based on the location, size, price, and other factors. So this is the famous data set, house price predictions. So already it is a very familiar data set available in the Kaggle data repository. Then financial forecasting. This is for mainly used for stock. So trend analysis. This is also the stock market analysis. So what is the trend going on? And then marketing. So time series predictions. So in this application, cases, we are using regressions. Before that, we have to clear clear difference between the regressions and the classification. So classification here is the classifier divide the inputs in two classes. So in the above set, the parrot green dots are more. So to classify the above part is parrot green inputs. So in the below the classifier, it is having some copper sulfate blue color values. So it's separated the two inputs, separated the two classes. One is the parrot green, another one is the copper sulfate or copper chloride. Even though there is some parrot greens, the classifier is not 100% classified the input data. There are some mixing, but major it is classified the two classes, A class and B classes. Whereas the regressions, then so there is we form a model that is a straight line, that is y is equal to mx plus c. So in the model, how the inputs are away from the model. So here there is no classification. The regression, that we draw one model, that is a one line. In the input, how far it is different from the models. So this way, but better regressions, all the inputs are sit on the line. Then only it is a good regression. But even though it is not that much accuracy, so the model is very close to all the inputs. This is the basic difference between classification and regressions. This is another simple examples of regression and classification. Regression in the sense, what is the temperature going to be tomorrow? So there is no if then else. There is no classification. What is the temperature on tomorrow? So here predictions. We are going to predict the value. Whereas the classification, what will it be, the cold or hot? So there are if then part. So there is two things. So one is the hot. It may be a hot or it may be a cold. So this is the classification. So in your research work or proposal, you are doing any research means which means we are going to address in the research, whether you are going to regression or classifications. So classification in the sense an else part. If cold or hot. Whereas the regressions, there is no if then, that is hot, cold or hot. There is no two things. Whereas the classification only both the sun and hot and cold. So this is this is very important thing while doing any project, whether we are going to apply the regression or classifications. So definition for the regression. Regression is a supervised machine learning technique used to model the relationship between the dependent variable and one or more independent variable. This is another definitions. That is a slightly next step of the definitions. Relationship between the dependent variable. So dependent variable is nothing but target variable and one or more independent variables. It is predictors. For example, goal, predict the continuous values. This is well suited for the continuous values. For example, predicting the house price, stock market trends, and sales forecasting. Already we have seen in the applications of the regressions. So regression modeling is the process of determining the relationship between one or more independent variables and one dependent or output variables. So examples, predicting the height of the person or weight of the person. If we are giving any height of a person means it will give the weight. So this is the predicting. So predicting the price of the car given the car model, year of the manufacturing and mileage, then engine capacity. So these are the predicting features. These are the predictors. Here we are giving only one variable. This is the more number variables. This comes on our syllabus. So based on the type of the function used to represent the relationship between the dependent or output variable or independent variable, the regression models are categorized into 4 steps, 4 models. A simple linear regression, multiple regression, then logistic regressions, then lasso regression. There are a lot of regressions, but in our case, I've never selected multiple regressions. So simple linear regression assume that there is only one independent variable x. If the relationship between x independent variable and y dependent or the target or the output variables, you can say in either way, dependent, output, target, all are same. Or a plus bx. This is a straight line. That is the equation of the straight line. Then the regression model is called as a linear regression model. Next is a multiple regression. Assume that there are multiple independent variables, say x1, x2, etc., xn. So in the car example, it will predicting the price of the car given the values like car model, year of manufacturing, mileage, engine capacity, etc. This is comes under the multiple regressions. So assume that there are multiple independent variables, say x1, x2, etc., xn. If the relationship between the independent variables x and the dependent variable of target or the output variable y is modeled by the relations same straight line equations, y is equal to a naught plus a1 into x1 plus a2 into x0. This is the model. Next, regression analysis makes it possible to infer or predict another variable on the basis of one or more variables. In this picture, there are the independent variable predictors. So what are the inputs here is, this is nothing but, this is the that is a graduates degree education profiles. Then how many this is the times working hours, then age. All the three criteria will find out the salary of the particular person. So if you find out the salary of the particular person, means what are the input, then working time of that particular person, and then age of the person. For example, I am taking these three values. So here the three things is used to predict the salary of the particular person. So what what we will do here means measurement of the influence of the one or more variables to the another variables. So these are the influence of one or more variables on this output variable. There is another variable. This is the core concept behind the regression analysis. Measurement of the influence of one or more variables on the another variables. So prediction of the variable by one or more other variables. So both we can measurement and predictions will do by using the regression. So we will do both cases, measurement as well as the predictions. So measurement of the influence of one or more variables on the another variables. What influences children's ability to concentrate? So do parents' educational level and place of the residents affect the children's future educational attainments? This is another example, but this example is very simple. Predictions of the variable by one or other variable. How long does the patient stay in the hospital? So this is the predictions. Forms of the regression analysis. This regression, there is a one variable influence on the another variables. One variable, that is a target variable. Only if we are giving the age of the person, it will give the some salary of the particular person. So this comes under the simple linear regressions. Then multiple linear regression means here hours and then age. So here more than one influence variables given into the system. It comes under the multiple linear regressions. Then logistic regression means here the classifications. That is whether based on the salary, whether the person is happy or not happy. So here there is a classification, that is more than one class. Whereas this linear regressions, there is no classification, only it will predict the values. So please go through this slide. It is very, very important to understand what is the difference between simple linear regression, multiple linear regression, and logistic regressions. So in the linear regression, there is the target variable is only one thing. Whereas the logistic regression, the target variable is more than one. So based on the salary, whether the person is happy or not happy. So the same way we can apply the medical industries, that is a cancered or not cancered, likewise. So the form of regression analysis, example, simple linear regression. Does the weekly working time have an influence of the hourly wage of the weekly working time. Multiple linear regression, weekly working time and the age of the employee. Here, two variables come into the picture. For multiple regression, multiple linear regression, week time and age of the employees has influence of the hourly wage. That is nothing but a salary. In logistic regression, has the weekly working time and age of the employee have influence of the probability having at least one employee. It is a dependent variable and the one is a independent. Here the brown color indicates the dependent variable, the green color is the independent variables. Probability having at least one employee. Another part is after we created a model, regression model for our data and find out the predictions value. Everything is good. Even though it will give the good answer, we have to find out the accuracy. That is evaluated the model. We have to validate our model. For regression, there are 4 metrics available. How will you evaluate our model, whether our model is good or not? By using the 4 metrics: mean squared error, root mean squared error, mean absolute error, and R squared. So these are the very important 4 metrics for validate our model. How do you say our model is good or not? By using these 4 metrics. Error, root mean squared error, mean absolute error, R squared. So before that, we form the linear regression model. And that model we are giving our input, it will work fine. Even though it will give the good answer, we have to prove our model is doing the best prediction. How it is means this is the standard metrics to measure our model. So mean squared error, root mean squared error. This is nothing but the root of the mean squared error. So mean absolute error and R squared metrics. These are the 4 metrics. Now we will see one demo. This is the example for linear regression model. So first we have to, as usual, import the necessary libraries, then load the data set and prepare the data, then split the data into training and testing data set. Already you know that we have to split the data set for training and testing. Why I am insisting here means the next topic is overfitting, comes this part only, training and data sets, training sets and data testing set. So far we are the previous case we are using only the 3 students marks, that is maths marks and physics marks. There is no testing and training. So in this example, we slightly move to the next level. The data is split into training data and the testing data. So then train the regression model. We have to train the regression model by using the training data. Then make predictions. We have to evaluate the model. Already we said, we discussed in the session, we have to evaluate the model. Then finally visualize the result. So these are the steps behind in the linear regression model. So first import the necessary libraries, load the data set, prepare the data. Is there any missing values? So all the pre-processing things are taken here. That is prepare the data. Then split the data into training data and the testing data. Then train the regression model. We have to create regression model. In that model, we have to train by using our training data set. Then once the model is ready, we have to predict by using the testing data. See, for training, we are using training data. For testing, make the prediction, we have to use the testing data. Finally, we have to evaluate the model, then visualize the results. So these are the basic steps for linear regression model. So step 1 is import the necessary libraries as usual, NumPy, Pandas. Then sklearn model selection, import train test splitter. So this line used for splitting the data. This is for splitting the data. That is training and test data. So this the sklearn itself do this work internally. So test data. Suppose if we are giving the 100 records, 100 students values means 100 students values given in the data set means, so randomly it takes the 80 students data for training and then 20% for testing data. So the separation or splitting is done by this line, train test data. Then sklearn lead. The sklearn itself, there are models. There are a lot of models available: sequential model, linear model, classification models. There are a lot of models available. In this example, we are import the linear regression model. So import linear regressions model from the linear model. Linear regressions we are using. Then in the sklearn metrics. So this is for evaluation purpose. Already we discussed mean squared, root mean squared value R2. So there are 4 metrics. For simplicity, I am using only the 2 metrics. So that is the root mean squared, the mean absolute error. I just leave it, then R squared. So I am only consider the 2 things, R squared and the mean squared R. If possible, you can calculate all the 4. That is not a matter. For the time availability, I am taking only the 2 things. Moreover, the 2 is a essential one. Then we have to load the data set. Here, example data set creation. Here we are creating the data set. That is a live data, new data set. You can take it from the Kaggle data set or IEEE data set or UCI data set or your real data set. By using any Google form, you can get the data. For simplification, here I am creating a data set. That is experience. That is 1 year, 2 years, 3 years, up to 10 years. The salary of the people. 1 year experience means it will get. That is a randomly I am taking 45,000, 50,000, 60,000 like this. This is the our input data. What is our salary? So experience and then salary. So it is make it as a data frame. Otherwise, you can load it from the .csv files from your data set. Okay. Then the third one is prepare the data. So here we are mentioned only the 2 features, that is experience and salary. Only these 2 values given in our program, but it doesn't know which one is the target features. So that we have to clear the, we have to given the informations to our program. That is features, experience. That is features is the input features. Target is a salary. This is for x-axis. In x-axis we are having experience. Y is a target salary. So what is our test? Automatically it will find out the salary of the 12 years person. Is it clear? What we are going to here, do here means, so already we are having some sample data, that is a year of experience and some salary of that particular year of experience. What we are going to test means, so if I am giving the 12 years experience means the 12 years is not in the data. So our model will predict, so the 12 years experience means what is the salary of the 12 years person. Is it clear? Yes, definitely more experience, it will give more salary. In this simple case, it is very only one features. So whereas the multivariable linear regression means we have to consider education. So suppose if the person is completed a UG level means there is one level of salary, PG or PhD or means it may differ. In this case, only one variable, one dependent, one independent variable. Okay. Sure, ma'am, I will share. So here we mentioned our what are all the features, what are all the target. So input feature is experience, output is the salary. So print DFF column means the index is salary and then experience. So that is experience and salary of the column name. So input Seaborn as SMS, we have to plot it as the scatter plot for the given values. So in the x-axis we are having experience, then one is a salary. So in this way, when the experience already the SAR told the right concept, the experience is increases, the salary also increases. So this is the picture regarding the given data set. So next, here only the algorithm starts. Our work is starts. Step 4, split the data into training and testing data set. So for this, X train, X test, Y train test split. It is a inbuilt function. Train test split is equal to our given X, Y. Test size is 0.2 means it is a 20. Here we are having 10 data set, 10 entries. So 10 entries. For 80, it is used for training, 20% for testing. So random state means random state is equal to 40 means every time the same 8 row is used for training, the same 2 row for testing. So if the random underscore state clear what is going on in this, so that we are giving the random underscore state is equal to 40. It means how many times you are running this program means the same 8 rows only considered for training, the remaining 2 is considered for testing. See here the record is 1 and 8 is not, so total to 9. So here 1 and 8 is not there in that X train. So X train, it is separately for X train, it takes only the 8 values. For test, it takes the, this way we are splitting the data. Then print Y train means the output target values, that is 75,000, that is salary. So X train means only the experience. Y train means the target value. Always Y means target, X means experience, that is input, input values. That is features. That is features is input, target is salary. Then Y test means 95,000, that is if we are giving 8 years means it will give 95,000 salary. If we are give 1 means 50,000 salary. This is a Y test. So the entire data set is divided into 4 parts: X train, X test, Y train, Y test. So understand? Now we form the regression model. trained a regression model. Model is equal to linear regression. Already we mentioned in our live. Simply we are building functions. Model is equal to linear regressions. In the model, we have to fit the X train and Y train value. So now the model is ready. Now we have to predict the value by using X test. Because X test we did so far we didn't use. That is 8th record and the first record. So that is 8th record and first record. In this X test only it is giving the experience. It have only the experience. This value is given to the model. So what it will predict. So after the predict, for clear understanding, I make it as a data frame. That is predict X test. The output is for 8 years actual in our data set. For 8, the salary is 90,000. For one year of experience, the salary is 45,000. But what our model will predict? For 8 years, the actual value is 95,000. So the predicted 95,172 point something. So it is more or less same. That is near. For 1 year of experience, the actual value is 50, but it predicted 52,327. So this way, it is our model is predicted. Is it clear? Now, testing with the new data that is not in the data set. Not in the data set. So now we creating on new data that is experience 12 years, 13 years, and 1 year. 1 year, whether why I am giving 1 means whether we have to check. So already the 1 year of experience, the person will get 50,000, even though it is already value. I'm giving the new data set that is for 1. So create the data frame, the same concept. Print. Now I am going to give the new 3 data that is 0, that is 12, 13, 1 years. This is the index, data frame index, not the experience. 12 years experience, 30 years experience, 1 year experience. Y predict is equal to model.predict. I am giving the new data frame. So now the Y prediction is over. So here the array is equal to so 1,13,534 for 13 years above the 1 lakh. So for a 1 year experience, now the values is equal to 50 to 46. So there is some slight difference in our model to the actual data. Reason that, so what will we do? We have to get the 100% accuracy, means the training data is not that much sufficient. So we have to increase the training data. So clear? So instead of 50,000, it will give some 46,000. So there is some 80% accuracy in our model. Why? Because the training data is not sufficient. So next, evaluate the model. So how we have to evaluate it? Here we are considering only the 2 metrics, that is mean squared error and R2 square. This is standard metrics to evaluate the linear regression model. This is the formula for mean square, then R squared value. This is the description for metrics. So MS is equal to mean squared error, Y test and Y predictor. Here we have to give Y test and Y predictor. Because Y test already we know. This is the Y test. For 8 years, we are giving 95,000. For 1 year, we are in the data set 50,000. But Y predict is 95,172. For 1 year, 52,327. So we have to calculate the error between this Y predict and Y test. So that this is the input given for this mean squared error function. So R2 is equal to R2 underscore square is equal to the same y test and y predict. So here, what is the mismatch between the y prediction and y test? So print the mean squared error MSE, then R squared error R2. The accuracy of our model is equal. So this is the final answer. So the mean squared error value is equal to this much, and R squared is this much. So the third step is very, very important. The accuracy of our model is 99%. So why the 1% is missing? Due to the lack of training data. So 8 data is not sufficient to train the data up to 100%. So visualization the result. So scatter plot, X test, Y test, color blue, and the label actual. The plot X test, Y predict, color lead. So that is X test, Y set, that is blue color. The prediction color is red color, label predicted. This is the blue for actual, red for predicted. So the X label is experience, Y is equal to, Y label is a salary. The title one, experience versus salary. So show. So this is the, so what it implies for 9 year, for test data and prediction data, this one. For 8 years, that is 95,000. It predicted 95,172. So that is nearer. Whereas for 1 year experience, the value is equal to 50. Instead of 50, it is giving 52. So there is some changes, slight changes. The model is not fitting the line, straight line. So there is a gap between model and the actual values. So this is the for one test data, it will give the 99% accuracy. Whereas the another one is there is some slight difference. So this is the visualization representation of the linear regression output. So what we'll do, we go with some other model, that is a random forest model. So this is not in your syllabus, even though just I explain. In this random forest model, in this case, the closely nearer to the actual value, whereas the 8 years experiences are not, that is 10 years experiences are not in the that much very closer. So the random forest is also not suitable for this input data. The model is good. The only thing is the training data is not a sufficient one. Now I will share this. Yes, sir. Low accuracy means the lack of training data. So for training the model, the 8 number is very, very less. Okay, sir. Hello, ma'am.
Voice please. Madam. You have kept your at mute, ma'am.
Okay, okay. No, ma'am, I'm just waiting for the participants to access my collab sheet notebook. Just I'm giving 5 minutes to them. So, random forest is not in our syllabus. Just I practiced in that notebook, sir. Next topic is, so this is the topics inside in your module 2. Dimensionality reduction is completed. Subset selection is over. Principal component analysis, regression, linear regression with one variable, linear regression with multiple variables over, sir. So the blue part is from 7 to 11. We will see in the afternoon session, sir. This is my plan. So do you want anything? I will do, sir. Suppose if our in our data set the linear regression is not the, even though in our example it will give some 99% accuracy. So the for the simple data it will give 99%. Whereas the so that time the linear regressions will not give that much accuracy. So we will go with some other technique, that is a random forest or SPM. By this we have to involve the ensemble techniques. So ensemble technique means we are merging the more techniques to get the 100% accuracy data. So this is the next step. So any queries? Yes, sir. To achieve more accuracy, we have to combine the more techniques. That is called as ensemble techniques. Thank you, sir. And one more task for regression. So already you may familiar with the data tab. Directly you can go to the data tab. already it is there. This is nothing but online statistical calculator. From this, we can use our own data. That is, export or import the data. But the given data is a sample data given by this data developers. So once you clear the data, and export your new data. So this is the sample data already there in the data type. So there are a lot of methods available. In our case, regression. So simple regression. Here the dependent variable, what we discussed in the theoretical part. So there are the independent variables. That is, independent variable is target variable. The dependent variable is nothing but a dependent features. So the age, academic degree, based on the academic degree, what is the salary? It will give the values, a predicted variable, not master degree. SAR said MA with a PhD, so not master is the correct. By using that, there are some mathematical and path is available. In free time, you can go and refer it. This is a data tab. It's an online statistical calculator. Or age and salary. This is the pictorial representation of the data. Then PC is also available. You can choose any type of will give the summary also. Yes, sir. Data tab is a very free tool, but up to some level only. After that, it may ask for some payment. For student purpose, it is a very useful for a laboratory exercise.
Ma'am,
Yes, ma'am.
ma'am, any queries, ma'am? Shall we wind up the class?
Any queries from the participants? For my side, okay, ma'am.
Dear Professor, any queries? Okay, thank you so much, ma'am. The class was very interesting, and thank you for your wonderful session, ma'am.
Thank you, ma'am. Thank you all. We will see by 2 o'clock.
2 o'clock afternoon section we can join with same link, ma'am.
Okay, ma'am. Okay, sure. Okay, sure.
Thank
Thank
you.
you all. Thank you all.